Hi, this is Rick Powell from Nanoprobes. You probably know us from our gold nanoparticle products for microscopy, particularly electron microscopy and pre-embedding labeling. Well, I'm here to tell you today that we do blots too, and I'm going to talk about two products that we make that are excellent for Western blotting. And you can detect his-tagged proteins or native proteins rapidly, consistently, and with high sensitivity using these products. Now, we have two product lines. For detecting polyhistidine-tagged proteins, his-tagged proteins, such as recombinant proteins, you would use Blot. And for detecting native proteins that don't have his or other tags, you would use Enhancement. First up, Blot. Blot's for detecting recombinant his-tagged proteins or other his-tagged proteins. It's a detection system which has two components, nickel NTA nanogold, and that's gold nanoparticles functionalized with the nickel nitrilotriacetic acid chelate, and that binds strongly to his tags. And the second component is a gold enhancement solution that makes the gold nanoparticles visible by autometallographic development, which is the deposition of more gold to generate a visible signal. And at the bottom of the page you'll see a link to the catalog page on our website that will give you more information about Blot. So to describe these components in a little more detail, here's nickel NTA nanogold. It has a small nickel-2 chelate, which has two vacant adjacent coordination sites, and those bind strongly to histidines. And because it's a small molecule, it has high resolution, and it binds very strongly, as strongly as antibodies. It's better than anti-His antibodies for several reasons. First, it's consistent. There's no variability to worry about between different antibodies or different batches of antibodies. It binds strongly and specifically. The binding constant is about 10 to the 13 moles to the -1, similar to antibodies. Gives denser binding because it's a small molecule. More of them can get in and bind per unit area. With denser gold particles, you generate a darker, stronger signal. And it's stable. It's a small molecule with a long shelf life. Here's how gold enhancement works. Basically, gold nanoparticles catalyze the deposition of metallic gold onto their surface from the gold enhancement solution. As gold deposits, the particles grow in size, and they can reach as large as 3 to 10 nanometers for EM applications, and up to 50 to 100 nanometers or larger in size, making them readily visible by light microscopy or on blots. The combination of gold nanoparticles with gold enhancement is a better detection system than DAB. Gives a strong dark signal with high contrast, purple to black color, which is readily differentiated from other stains. High signal to noise, clean signal, low background. There's minimal diffusion of the deposited metal, so the signal stays sharp. And it's permanent. The color doesn't fade, so you can archive your Western blots with confidence. The procedure gives you sensitive results in 1 hour and 15 minutes. So after transferring or blotting the his-tagged proteins onto your membrane, you wash with TBST, tris buffered saline, with 0.1% tween 20. Block. Apply the Blot NTA nickel gold incubation for 30 minutes. Wash with 50 millimolar imidazole, followed by deionized water, and finally develop with gold enhancement for about 10 minutes. And the link to the instructions for this product, which gives the complete procedure in more detail and discusses other tips and tricks for it, is at the bottom of the page. And this is the result you can expect using this product. And on the left you can see a protein reference ladder with different molecular weight proteins. The next 5 lanes are decreasing concentrations of, or decreasing amounts of a his-tagged ATF1 protein detected with Blot. The next 2 lanes, or after that, are 2 different proteins mixed with an E. coli extract. So that shows the detection is still clear and sensitive and sharp, even in the presence of cell extract or other proteins. And finally, on the far right lane is an E. coli extract without the his-tagged protein, showing that there is no signal with the extract, so still a very specific binding. To sum up, Blot gives you consistent performance with no variability to worry about between different antibodies, binds strongly and specifically, just as strongly as antibodies, gives denser binding, so a darker, stronger signal, and it's a stable molecule with a long shelf life. Now on to Enhancement, and Enhancement is the way to detect native or non-his-tagged proteins. And what Enhancement is a metallographic peroxidase substrate, and it replaces DAB or organic chromogens in any peroxidase probe procedure. Enhancement is a universal substrate. It's highly sensitive and precise, giving a sharp black signal and negligible diffusion. It's rapid and it's permanent. Develops in a few minutes to give a permanent signal. So as with Blot, you can archive with confidence. This is how Enhancement works. The peroxidase deposits metallic silver from a solution of silver 1 ions and other reagents to give black, very highly visible deposits of metallic silver. And at the bottom of the page we have a link to our catalog page for Enhancement. Don't be put off by the ISH and IHC, it's for blotting too. And here's the protocol to get super sensitive results in about an hour. So after you've probed with the peroxidase probe, you then wash with TBST or PBST, tris buffered saline or phosphate buffered saline with 0.1% tween 20, followed by deionized water, followed by the Enhancement. And there's 3 components to the Enhancement. There's Enhancement Detect Solution A, so you apply that first, wait 4 minutes, then apply the second component, Enhancement Detect B, mix them, incubate another 2 minutes, and then add the final component, Enhancement Detect C, mix, and incubate for 9 up to 25 minutes if necessary. Keep an eye on it, and stop when satisfactory staining is observed. Rinse thoroughly in deionized water, dry, and you're good to go. And at the bottom of the page here, you'll see a link to the instructions for this product, which gives you a more detailed protocol, more information, and tips and tricks. Here's the type of results you can expect with Enhancement. On the left, there's unmodified DAB. In the center, nickel-enhanced DAB. And on the right, Enhancement. And as you can see, in this case, the Enhancement signal is 5 times as sensitive in terms of the amount of protein detected as even the nickel-enhanced DAB. So to sum up, Enhancement is sensitive, detects smaller amounts of target than DAB or metal-enhanced DAB. It's quick. The procedure takes about an hour. It's easy. You only have to change 1 step. Everything else stays the same, just the final detection, applying the peroxidase substrate. It's universal. Substitutes DAB or any other peroxidase chromogen substrate in any procedure. And finally, it's a very high contrast, sharp, black, opaque stain that's easily detected, visualized, and differentiated from other stains if you want to probe for a second target. So reviewing how we do Westerns, for his-tagged proteins you'd use Blot, which is consistent, binds as strongly as antibodies, gives you very dense binding, and it's stable and produces stable, permanent results. And for native proteins without his tags or other modifications, you would use Enhancement, which produces highly sensitive staining, better than DAB or metal-enhanced DAB. It's easy, you only have to change 1 step, although you may reduce the concentrations of primary antibody, secondary antibody, or probe. It's universal, can substitute DAB or any other peroxidase substrate, produces a high contrast, sharp, black signal which is easily detected, visualized, and differentiated, and you get good results in about an hour. For more information about these, or any of our other products, please go to our website, www.nanoprobes.com. Thank you very much for your attention. This is Rick Powell from Nanoprobes. Have a great day and successful Western blotting.